Welcome to part 2 of our test 1 review. Using the class data set, we want to calculate the 5-number summary for height in inches, rounded to 2 decimal places. So that 5-number summary as I have on here displayed. The minimum, first quartile, median, third quartile, and maximum for the height. So let me open up that data set. That would be this one. So to find the minimum, we are going to be doing equals min of column A. For the first quartile, this would be quartile.inc of column A, and the value we are going to use for this will be 1 for the first quartile. The median would be equals median of column A. The third quartile would be equals quartile.inc of A colon A, comma 3. For the third quartile, the maximum would be equals max of A colon A for that A column. So based upon those numbers, we have a minimum of 59, first quartile of 64, median of 66, third quartile of 70, and maximum of 75. So let's write all those out. The minimum then would be the this would be there we go. As my pen decides to stop working on me. The minimum height is, from what we found, 59 inches. The first quartile height is 64 inches. The median height is 66 inches. The third quartile height is 70 inches. And then the maximum height, let me just scroll down for that. The maximum height is 75 inches. So the 6th part of this particular one, I want to know from that 5-number summary what the shape of the distribution would be for the height. So from that, and let me just scroll this back up to make note of it. The difference between the first quartile and the median, a difference of 2. The difference between the median and the third quartile is a difference of 4, so that's bigger. From the third quartile to the maximum is 5, and from the first quartile to the minimum is also 5. So because there is that difference between the median and the third quartile being larger, that means we would have a bit of a skew to the way that this distribution would look, right? Since the 2 whiskers would be roughly the same length, right? But the box, though, however, on the other side, would be slightly longer on the right-hand side. So because of that, this is going to be a skewed right distribution. So the last part here wants to know if there's any outliers in the data set. So we are going to need to calculate the 2 fences. The lower fence takes that first quartile minus 1.5 times the interquartile range. We have the first quartile to be 64. We're going to subtract 1.5 times the interquartile range. The interquartile range takes the first quartile the third quartile, excuse me, minus the first quartile. So 70 minus 64, that gives us a difference of 6. So 6 is our interquartile range. Doing this out would give us a value of 55. Likewise, we need the upper fence. So third quartile plus 1.5 times the interquartile range. So 70 plus 1.5 times 6. This would give us 79. Right? And if we were to look at the data set, as I pull this back up, data set. If we were to look at this data set, none of these values, as we can see there on the left-hand side, are less than 55. Likewise, none of them are greater than 79. So because of that, we have no outliers. So due to these fences, there are no outliers. For question number 5 on here, I have the border tab, which contains the number of border encounters for a country for a year, and we want a frequency chart in a new tab. So the number of border crossings, and I want a specific name for it, the border frequency chart. So that would be this tab here in my Excel document. As you can see, we have each of those months and the number of immigrants. So for us to do this, we need to select this data and go to Insert, Pivot Table. And where it says this, hit OK. And this pops up. So to actually get that frequency chart, the month is going to be the rows in our case. And the number of immigrants we are going to use for the values. And as you can see, it provides us this table. And as requested, I want to change the name of this tab to Border Frequency Chart. So where it says the title of this tab, in this case sheet 1, we are going to double left click that. And as you can see, it highlights that name on it. But for this, we want to name this, as I requested, Border Frequency Chart. So border border frequency chart. And then just hit enter, and it will save that name on there. The next one that I have, number 6, I have a survey of 1,400 American households, found that 35% of the respondents own a computer. This is based on a survey of 1,400 American households out of 3,000 American households sent this questionnaire. We want the sample for the scenario. So based on whom they sent this to, they sent this survey to 1,400 American households, not the 3,000. They tried to send it to 3,000, but 1,600 of them failed to respond in some format. So the sample is the 1,400 American households. The population for this, again, not the 3,000 because they sent it to all 3,000. Only 1,400 responded. The population, the overarching group this is describing, is all American households, which was not given a number in this case. And the third part to this question wants to know if that 35% that's stated in this problem, if it is a parameter or a statistic. So the 35% was given about the respondents in this case. So to answer that question, this would be a statistic. And why is that? And that is because, and let me just move this down so I can write on here. That is because the scenario defines the sample. Scenario defines the sample. Thank you for watching this video, and let me know if you have any questions or concerns, and be on the lookout for part 3. Thank you.